defining a parameter statistic. So what is a parameter? A parameter is a summary of the population. And again, there's a lot of things I'm not saying here. So a parameter is a summary. Again, what is a summary of some measurement of the population? So maybe, again, I should throw in the word summary of the population, but I'm going to do this. A parameter is a summary of data from the population. Okay. A statistic is a summary of the data from a sample. So both of these are summaries. So parameter is a summary, statistics is a summary. The difference is this one is the data that is coming from the entire population. Okay, a statistic is a summary, but it only comes from the sample. So how often we'll be able to calculate a parameter? Unless the parameter, the population is very small, the answer is never. So the reality is the purpose of statistics is to estimate a parameter. So so that's really the purpose. If you know the parameter value, you don't need the statistic. So the only reason we sample is because we cannot, or we don't know the parameter of a population. Okay, so another thing to keep in mind is a parameter is a fixed value. It doesn't change unless the characteristics that I mentioned, this part, unless the characteristics that create it are changing, and then the parameter changes. So parameter is a fixed value, while a statistic varies from sample to sample. Okay. An elementary school holds 500 children. You want to know the average weight of the 500 children. You measure all the children, and the average weight is 56.3 pounds. Is the value of 56.3 pounds a parameter or a statistic? What is the symbol used? All right. So one thing to notice, the population is implicitly stated, meaning they're not going to say this is the population. but it's mentioned here. It consists of the 500 children. Now, how do I know this? Because it says here, okay, the elementary holds 500 children, and you want to know the average weight of 500 children. So this is the goal. It's just you're describing the goal here. So a population is defined according to your goal. That's all we want to know. So if all we want to know is the average of those 500 children, then the population is those 500 children, okay, inside this elementary school. So now is the 56.3 pounds is the value of 56.3 parameter or a statistic? So this says you measure all the children. All the children are measured. So if that's the case, the 56.3 pounds, sorry, is a parameter since we measured everything in the population. Okay, so let's go over this. So we determined that this is all the population, 500 children. You measure all the children, and the average weight was 56.3 pounds. Notice that 56.3 pounds, this is a summary of all the 500 data points. Okay, so this is all the summary of everything. So if that's the case, the 56.3 pounds, that has to be a parameter because, again, it's a summary of all the data that's from the population. And what is the symbol that we used? So, for example, let me also mention this. So the population, again, just to get some context. Again, if you look at the data, it could be something like, for example, you measure one child, 40.9 pounds. Measure another child, 50.7 pounds. Another child, 65.61 pounds, and so on. So again, notice our data again is this is going to be quantitative data. And also, again, we think of weight as being continuous, but so we can say it's continuous as well. So the parameter here is an average, 56.3. So we're going to use the following symbol. The parameter for the average which is also known as the mean. The average is also known as the mean. So notice we're going to use the word mean more than we'll the word average in this class. It is symbolized by the Greek letter And it looks like this. It's it's described by the word mu. So this is the Greek letter mu. Okay, the name of it is the mu. Okay, so we would write something like this: mu, or the mean, is 56.3 pounds. Okay, so got another one. An elementary school holds 500 children. You want to know the average weight of 500 children. You measure 100 children at random, and the average weight of the 100 children is 52.7 pounds. Is the value of 52.7 pounds a parameter or statistic? So notice the same scenario as above, but now notice that we're only measuring 100 children out of the total of 500. So same scenario as above. But we are only sampling a subset of 100 out of 500 children. So this is a statistic. Since we're not measuring everyone. Okay. The symbol used for the sample mean is this. The letter itself doesn't really matter, but we're going to use X. So if I write if my measurement is defined by the letter X, then what we'll do is call this thing, the sample mean will be called X bar. If my measurement of children had been C, for example, then we would have used the following as a symbol, C bar. Okay, so there's really nothing magical about the letter. It's all about the little bar across that makes it the sample. Okay. So in this case, let's say that we call it, just for fun, since it's the weight of children, our measurement is symbolized by the letter W. So our sample mean is now described by this. So in the case will be W bar equals 52.7 pounds, which is an estimate of, and notice as I'm calling this measurement W, then I'm going to add a little more thing. Mu describes the mean. Really the bar is what describes the mean. Okay, but because this is the mean of the population, and now my variable is called W, sometimes what we'll do is put a little subscript. So it's the mean of the variable that's being measured with the letter W, and it would be 56.3 from above. Okay. So again, if we measure this in W, it would be mu of W. Again, mu signifies population mean. Okay, let's look at another example here. Consider a fair coin, of which one side we will call head and one side tails. What is the chance the coin will land on heads? Is this value a parameter or statistic? Okay, so what is the chance the coin will land on heads? So the probability of landing on heads. All right. Well, if it's a fair coin, sorry, I'm going to assume that it's half the time it will land on heads. Okay, so I think you would agree too. The probability of landing heads is half. Okay, so what if I ask you tomorrow? Would that change? No, it doesn't. Notice this value is fixed. It's not changing. Does not change. Okay, there's no changing. Now, what will cause it to change? Well, if you somehow alter the characteristics of the coin, so one side does land more often than the other, then of course that value would change, but then it would change and they stay fixed at whatever um, value represents now the chance of it landing on heads. Okay, so because of this, and it fully describes the population, the chance of it landing heads. So the fact that you come up with this number, meaning this is fixed, it's not changing. So because of that, this is a parameter. Meaning it fully describes the chance that the coin will land on heads. It doesn't change. It's in it, yeah, okay, we'll look at this in the next example. The symbol is P. And it's called population proportion. Okay, so we would write P is equal to 1/2. Okay, now let's look at the next example, just to see the difference between the two. Consider a fair coin. A coin tossed 100 times, of which a coin lands on the heads 43 times. What proportion of times did the coin land on heads? Well, out of 43 times, sorry, out of 100 times, 43 land on heads. So the proportion being 43 out of 100 over 0.43, 43%, the coin landed on heads. Is this value a parameter or statistics? Well, this came from a sample. So it is a statistic, which notice brings up to the a difference between these two. like in the children one, the weight, we don't know what the value of the average weight of the 500 children. We would have to measure all 500 children to figure out the average weight. This one's a little different in that how big, and there's 500 children there, but here, how big is the population? The coin scenario. Well, technically, the population is infinite. You can toss a coin forever. There's no ending to this. So the reason we come up with a half is not because we've tossed the coin or sampled or can actually measure the entire population. That's not possible. But we have logically come to the conclusion that there's only two sides to the coin. That when you flip it, either side is equally likely to appear. So out of the two sides, only one of them has the heads. So therefore, proportionally, this is what the chance of landing heads, and it's fixed. Versus this, when I actually toss it, of course, I got, in my particular toss, 43% landed on heads. So this one, if I did it again 100 times, I wouldn't expect to get exactly 43%. I might get 43% again, but I could also get 44 or 51 or 52. So notice this is the statistic. It is varying from sample to sample, right? The symbol used is called p hat. So a little thing has like a little hat on it, p hat. And this is the sample proportion. And again, if I break it down to what's happening, again, the data itself is going to just be this. This, when you get the data, it's going to be, somebody's going to be counting the tails, heads, 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 tails, 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 heads, tails, tails, heads, and so on, until we've done this 43 times. And then when I summarize the data, what will happen? Well, I have to count how many heads I got. And in this case, I had 43 heads, and we have 57 tails. Okay, so in this case, p hat will be 43 out of a total of, when I add these two numbers, I get 100, and there's my 0, 4.3, and this is a statistic. Also notice that this data is categorical. Okay, so this is categorical data. All it consists is of observing, it's symbolizing if it's a tail. So these are words, obviously, but symbolizes teeth, tail, heads, tail, heads. That's all the measurement can consist of here. So let's finish with the following here. From question 5, the sample of 40 Duracell batteries. Actually, that's not question 5. It was question something, but it wasn't question 5. The sample of 40 Duracell batteries lasted an average of 33 hours. Okay. Is this value of 33 hours a parameter or a statistic? And what is the symbol used? So again, because I'm only sampling 40 Duracell batteries, again, just like sort of like the coin idea, we can manufacture Duracell batteries for the next 700 years. Right? And let's say we, for some reason, decide to manufacture these particular Duracell batteries. So the characteristics stay exactly the same. So what I'm trying to say is that really the reality is that this is a statistic, right? It is a statistic. As we are sampling from all possible. So I guess what I'm trying to say is the 40 does not represent the entire population. It's just a sample. Okay. So in this case, It's a statistic. And what's the symbol used? Well, if I use, for example, X for the number of hours, this last and X bar would be 33 hours. If I, for some reason, decided to use H as my symbol for the number of hours for each data value, then this number would be 33 hours or H bar.